Hello, everyone, and welcome to our next episode of Knowledge and Know-How with NetApp Support. My name is Dwight Cranford, and I'm on the leadership team here in the NetApp Support Center. We're really excited you joined us today. We've got some great content we're going to share with you. If any of you were able to attend Insight, some of this may look familiar. We did do a theater presentation a couple times there, and what we're going to do today is a deeper dive into some of those things that we talked about during that theater session. Just a couple housekeeping things. There will be a live Q&A during this session. If you have a question, please put it in the chat and address it to all panelists. And also the slides will be sent out along with a recording of the webinar at the conclusion of today's session. We do make sure that everything stays private, so no one else will be able to see your questions, and you know, we do take security very seriously here, so no worries about that. So sit back, relax. Again, you'll get the slides, you'll get the recording, and put your questions in the chat, address them to all panelists, and we'll get those answered. Today we're going to talk about fabric pools and do an overview there. We'll then move into virtual storage grid and some best practices. And we'll also talk about managing and monitoring storage grid alarms. Real quick, I want to give you an overview of why we've kicked off these webinar series from NetApp Support. We want to be more proactive and build a better relationship with our customers. We don't want to wait for you to call in when you have an issue. We want to share our knowledge, and we want to show you tips and tricks with your setup and maintenance, and hopefully prevent some of those issues that you may see pop up. So again, this is just us being proactive, putting our customers first. We want to improve the overall customer support experience, and you know, webinars such as these will help you not only prevent some issues, but also better prepare before you contact support when you need us. So we'll go ahead and move into the technical content. I have three technical experts with us today. Logan Baez is an escalation engineer who specializes in core ONTAP, cloud volumes ONTAP, and hardware. He's been with NetApp for 6 years. Ahmad Mubarak is also an escalation engineer. His area of expertise is E-Series and storage grid. He's been with NetApp for 7 years. And then Matteo Novakovici is a storage grid escalation engineer, and his expertise is a storage grid platform, and he's been with NetApp for 10 years. So I'm going to hand it off to Logan now, and he's going to give us an overview of Fabric Pool. Logan?
Thank you, Dwight. Hello, everyone. Good morning. Today we'll be discussing, I'll be discussing Fabric Pool, just going over some of the tiering policies and just some common setup tips before I pass it over to Ahmad to continue with storage grid in a Fabric Pool environment, virtualized storage grid setup. So what is Fabric Pool, right? Quick overview. So here we have an all-flash fast system, right? And of course, as your data footprint increases, right, on your storage, you've got to purchase more storage, and you know, and over time, you will actually end up with a high percentage of inactive data, and that's just, it's a waste to those SSD drives, right, to its potential, right? You want to concentrate those SSD drives for your heavy workloads. So what do you do with all that inactive data, right? So imagine a healthcare hospital. You have tons of information that may not be accessed for months, years, right? Or you're a law firm. You've just finished a hot case. It's done. You stored it away. All the discovery, all the information is just sitting on your storage. May not be accessed again. 1 year, 3 years, 5 years, maybe never again, right? So Fabric Pool, right? NetApp created Fabric Pool, and what Fabric Pool allows you to do, it allows you to link your aggregate to an external storage capacity, right? So that can be either cloud storage or an object storage, including NetApp's on-prem storage grid, or of course the virtualized version of storage grid. We deem those tiering providers as our capacity tier, right? And then what we deem our primary storage we deem the term for that is the performance tier. So performance tier for your primary storage and your capacity tier for your cloud and object storage. So what we do is with Fabric Pool, we allow you to move that inactive data to this external source, and that'll actually reduce your data footprint. You're having to purchase additional SSD drives for your primary storage. So how do we determine what's an inactive block, right? Every block that's written on the storage is flagged as hot. Over time, we have monitoring scanners that will check the activity of each block and decrease the temperature, and that scan can actually be set from 2 to 63 days. So as a block sits there and it's not being read for however, depending on the minimum, right, 2 to 63 days, at that point, if that block hasn't been accessed, we mark it as inactive or cold and flag it ready for tiering. So once we collect enough 4K blocks, right, so 1,024 4K blocks, we combine that into a 4 megabit object, at which point we tier it again to your capacity tier, so cloud or object storage or storage grid. So how do we control what data gets tiered, right? So we do that during tiering policies. You enable your Fabric Pool on the aggregate, and then you control your tiering per volume, and you do that with your tiering policies. So first we have the snapshot only, which is the default when you create a volume, and we those cold blocks which are associated within a snapshot copy, and again these blocks are only within the snapshot copy, meaning they're not linked to your active file system, will get moved or flagged for tiering and moved to your capacity tier. Next we have an auto policy, which will take or associate cold blocks within your snapshots and your active file system. So all blocks, essentially, right? All blocks within your volume. And those are controlled with the minimum cooling period. So you can set that between 2 and 63 days. Just note that these two policies, they're currently set to not start tiering until the aggregate reaches over 50% utilized, 50% fullness. Next we have, and there's in the next slide, we've actually 9.6, you can tune that, and we'll discuss that in the next slide. Next we have an all policy, which replaces the backup policy in 9.6, and that pretty much just moves all blocks immediately to your capacity tier. So the backup policy before 9.6 was used for all destination type volumes within the SnapMirror relationship. You would use that for all to move all your blocks, and if you've got a SnapMirror data protection scenario. And last, we have a non-policy, which disables tiering on the volume, and if there are any blocks that were associated or in the capacity tier and you set it to none, those blocks will still remain there until they're read. One quick note on the all policy, just note too that all your data blocks will be in the capacity tier, which means all reads will be occurring from your capacity tier, not your primary storage. So you want to keep that in mind when you're trying to monitor performance reads. So some additional tiering tips. I mentioned this before. You can, so 9.4 and earlier, you cannot set the tiering fullness threshold, right? It's set at 50%. In 9.5 and later, you can tune that to whatever percentage you like, just using the following command. So can tiering be scheduled? No. When does the tiering, daily tiering scan happen? It'll happen once a day. We can't really predict when that'll occur. Again, you're constantly running, volumes are continuously being scanned, and as soon as one completes, the next one takes over. So we can't really predict when it'll occur for a particular volume. And I covered this on the last one. This is pertaining to the none policy. Again, if you set it to none, if you had prior blocks that were tiered, they will remain there until they're read and brought down. If you want all those blocks brought down, then you can use a vol move to immediately move all those blocks from your capacity tier back down to your primary storage, or other words, considered as your performance tier. So tips when you're configuring aggregates. All right, so all volumes in the aggregate must be thin provisioned. That's a guaranteed set of none. You can, so ONTAP won't even allow you to enable a fabric pool unless all volumes are guaranteed of none. In your cluster, we allow you to have multiple providers, so multiple either cloud providers or object storage providers, but you can only have one set per aggregate. So once that capacity tier is linked to your aggregate, it cannot be unattached. Again, if you want to make those changes, then you might consider using a vol move to move it to a different aggregate if you want to change object storage. There are some additional features that we're looking at in 9.7, so look out for those to assist with this. So what happens when the aggregate is nearing full, right? We have a couple alerts that we'll identify, and there's a couple things that the fabric pool and the aggregate will disable or enable depending on the fullness of that aggregate. So if the aggregate reaches 70%, so all writes from the cloud tier to the performance tier are disabled. So meaning any of your blocks that are currently in your cloud or object storage will not, if they're read, will not be brought down to your primary storage. You continue serving data and you will continue tiering. Again, this just means that all your reads will be occurring from your capacity tier. So when an aggregate reaches over 98%, tiering stops. We do that to make sure it doesn't reach full, so you can continue serving data. And again, we're past the 70%, so which means all your reads are still occurring from your capacity tier. Once that you add more space and we drop down to that 98%, tiering will begin, will resume automatically. And lastly, we have a monitoring, which will actually keep track of your capacity tier and will let you know once it reaches 85%. So one quick thing. So of course, we're talking about how to set up. So how can I determine how much data is inactive, right? And starting in 9.4, we introduced the inactive data reporting, IDR for short, as a tool to help you determine how much possible inactive cold data you might have within an aggregate. The IDR uses a 31-day cooling period. It's enabled by default on all SSD aggregates in 9.6. It's enabled by default on your fabric pool aggregates in 9.4 and 9.5, and it can be enabled on non-fabric pool aggregates using the command line. This also includes just regular hard drives aggregates starting in 9.6. And here's just a quick snippet which you can review using System Manager, and you get an idea of the reporting. Very helpful when you're trying to decide how much capacity tiering you're needing, or how much storage you can unload from your primary. So some networking tips during setup. So we recommend when you're setting up your fabric pool to add an additional lift, right? It uses the intercluster lift. So set an additional one, and also if you've got your snap mirroring. Why? Because fabric pool shares the same network with your snap mirroring, snap vault replication operation. So multiple lifts will improve performance, or at least you can determine and monitor your fabric pool traffic against your snap mirror traffic. And just in general, if you've got more than one intercluster lift and you've got different routing, so your snap mirror routing may be completely different than where you're routing to your capacity tier. So we highly recommend placing them in different IP spaces. Fabric pool can choose from multiple IP spaces, but it can't really choose which lift with an IP space to choose, right? So you may have a situation where it chooses a different IC lift, which is meant for your snap mirror, than what you intended. You intended it for your fabric pool traffic, so just keep that in mind. Of course, is there any interruptions in your intercluster lifts, or if it's disabled, tiering will stop, and communications to your external tier. So any reads will be disrupted when you're trying to make any, of course, reads of any blocks that are in your capacity tier. And lastly, just want to make this note that fabric pool is not a backup solution, right? It works nicely with our backup solutions, and it's actually it's a great setup if you've got storage for your destination volumes, and you go ahead and you have a snap mirror to a destination aggregate where you have a volume set to an all policy, and all that information is now tiered, right? So that's it for me. I'm going to pass it on to well, actually, we've got some questions before we continue.
Yep. So again, if you have questions, make sure you put them in the chat, address them to all panelists. Logan, we do have a couple questions here for you. Satish wants to know, can a user define block temperature?
No, you can't go ahead and set the block temperature for block. There's ways of doing that. If you want to maybe move all the blocks initially, then you can maybe use vol move, set it to the destination policy as all, and all those blocks can be moved. But essentially, you will have to wait for that minimum cooling period. You might decide to set the minimum cooling period to 2 days, and then adjust that once you have blocks moved. So that is an option, but you can't manually go in and set a block as cold or ready for tiering.
Okay. And then David wants to know, are storage efficiencies preserved when moving data to the cloud tier?
Yes, they are. The only caveat with that is if you're using the all policy, you may lose some efficiencies with inline efficiencies. That's just because if you set the all, as soon as it hits the NVRAM memory, it's automatically set and tiered off to capacity, so it doesn't give the opportunity for inline efficiencies to run.
Okay. Again, just a reminder, if you have questions, let's put them in the chat, address them to all panelists. And now we're going to move over to Ahmad, who's going to talk a little bit about virtual storage grid and some best practices there. Ahmad?
Thank you, Dwight. So my name is Ahmad Mubarak, and I'm an escalation engineer in the E-Series and storage grid products. And after Logan went over a few tips regarding fabric pool deployments, I want to take a few minutes and go over a few tips regarding virtualized storage grid nodes within fabric pool environments. And before I dive into those kind of configuration and some of those tips, I want to brief you on storage grid architecture. And primarily, I want to touch on the different type of nodes that you would typically see in a storage grid environment. So starting with the admin node, which runs the management services and monitors the health status of all the nodes in the grid. It also provides the capability of doing maintenance and upgrades and like expansions, software upgrades, as well as audit log services. And that audit log services are usually for trying to trace S3 operations or data retention rules and things like that. Next is the storage nodes, and those are typically your storage grid hardware appliances, and those provide the storage capacity, along with the services to actually read, write, and verify all the objects stored on disk. And next is the gateway node, and it is an optional, and it's essentially a load balancer that receives incoming requests or incoming S3 requests from the applications or from the client side, in this case, the PAS nodes, and distributes it in a round-robin fashion across all the storage nodes. Now, in case you're not using a gateway node, you may be using a third-party load balancer or DNS-based round-robin to round-robin between the different storage nodes. And last but not least is the archive node, and it is an optional node, and it's only used when you want to connect the grid to an external archival system in case you want to, back up to tape or something like that. Now, storage grid node deployment varies. There are different options when it comes to deploying a storage grid node. First, you got your hardware appliances, and those are typically your storage nodes, and we have different type of models and different type of configuration. We have one starting with 12 drives up to 60 drives, and recently we released the all flash hardware appliance as well. And next you got virtual machines, so you can deploy virtual machines within your ESXi environment, and that machine will be running a single node, whether a storage node or an admin node or a gateway. Typically, admin and gateway nodes are commonly virtualized, or, which is the third and fourth option, are run as a Docker containers within either a bare metal server that you may have in your data center, or a virtualized Linux server that you deploy within your ESXi environment. And having that Docker versus running a single virtual machine allows you potentially to run multiple applications or different containers within that one virtualized Linux server. So today I decided to talk about one topic when it comes to storage grid deployments in Fabric Pool environment, which is tiering non-appliance storage grid nodes. So those are your virtual machines or your Docker containers within virtualized Linux host. So like I said, that's one common or one example configuration that we typically see. And it's when the problem is when the data store housing those virtual machines or virtual machine is actually linked to a tiered FAS volume. That means the FAS volume that houses potentially the virtual, the VM files or the container object, the container files is actually combined into objects and then tiered into storage grid. Now, this type of configuration is supported, and we do have customers in the field running in that configuration. And but however, we did notice that in some unplanned event, or in case there were some unplanned events that impacts the availability of a virtual machine or multiple virtual machines, it can add some complexity when we're doing when we're troubleshooting issues in those environments. And for example, let's say you had some networking issues or communication problem, and one virtual machine became unavailable, or the data store went offline because the heartbeat failure, or we reached some certain timeout because of a communication issue of some sort. Then that's where the complexity may become when it's tiered, is because for example, if it is an admin node that is happen to be impacted, then the storage grid environment may still be serving I/O and processing requests from the FAS nodes. However, the user will lose that GUI or web GUI to be able to check on the health of all the nodes or do any maintenance on the grid. Now, an alternative would be logging in via SSH and checking on the health of all the nodes. Which is possible, and customers do have access to the passwords and login credentials to be able to check that. However, that will add some delay. Rather than having that one place to check all the nodes, you have to individually go to every node and check the status of the services, and that's where the complexity comes. The second potential complexity is if a gateway node is impacted. Remember, the gateway node is your point of contact for the FAS nodes or for the client side in general to communicate with the storage nodes. So if we lose that gateway node, then potentially the client will lose access to all the objects or tiered data. And that could also cause problems in the environment, depending on what that data is and how it impacts your application. Now, this may sound challenging and bad, but like I said, it is a supported configuration, and it's not a common issue. And one reason I can really talk about easily here is the redundancy and the overall redundancy that you have in those environments. So having the redundancy at multiple layers in that environment actually prevents these corner cases or these one-time events or potential events that may lead to some access or complexity problems. For example, like on the FAS side, you have potentially multiple nodes or multiple paths to communicate with the object storage. Or you have within your network infrastructure, you have multiple switches of some sort. Or on the grid side, for example, you have your data retention rules, where you can have a default to copy rule or erasure coding. So even if there was a problem communicating to, let's say, an individual storage node for some reason, that copy of that object is still available on other nodes, or it's erasure coded on multiple other nodes. So we can easily service that request from the client side with no impact to the client side and applications. And it is, there are those potential corner cases or single time events that happen, but like I said, can be avoided, however, with a few best practice steps. And let me get into those. So first, if it is a data store that is linked to a tiered FAS volume, we do recommend disabling tiering on that volume if possible, or see if you can move the storage grid virtual machine to a different location. Now, that may not be possible depending on your environment and how we understand how complex these environments can be, and simply disabling tiering on an entire volume or allocating a specific volume just for the storage grid virtual machines may not be possible. And that's fine. Another best practice or step you can do is deploy secondary admin nodes or gateway nodes for additional redundancy. So we talked about the different redundancy layers that you have in this environment. You can also add another redundancy by deploying a secondary admin node or a secondary gateway node in case a single gateway or admin node happens to be impacted. Next is the storage grid appliances. So in the past, we've only had storage grid appliances that could run storage nodes. However, with 11.3 release that just came out, we released SG-1000, which is a single 1U compute node that can run either a gateway or admin node. So your entire storage grid environment can now be running on hardware appliances. And in case it happens to be that a gateway node is impacted by an unplanned event, then and you have to restore or resume access to the storage nodes, we do have some instructions in the knowledge base article mentioned here, 1095.115, where it talks about what are the steps that you need to take to shift the client or the FAS nodes from communicating directly to the gateway nodes to actually talking either directly to the storage nodes or doing some DNS change to round robin between the different storage nodes using DNS entries. And that sums up the best practices for those kind of deployments. And before we move on to the next topic, I want to pause here and allow for a few questions if we have any.
Yeah, so again, if you have any questions, make sure you put them in the chat, address them to all panelists. Ahmad, we do have a couple questions for you here. Nicole wants to know, or she asks, we have a single storage grid site. Can we deploy multiple admin or gateway nodes at the same site?
Yes, you do. So you can deploy multiple admin nodes or gateway nodes at the same site. Now you can only deploy one primary admin node. The second admin node would be a secondary, which can do almost all functionalities as the primary admin node. However, it cannot do major maintenance. For example, upgrades, expansions, things like that. The secondary admin node cannot run, and it's not advisable to take any maintenance actions when you have a node down in a storage grid environment in general.
Okay. And James's question is, does storage grid support vMotion?
So yes, we do support vMotion for our virtualized nodes, like admin or gateway node. However, we do ask that you stop services and do it offline when you're doing the operation.
All right, thanks. I don't see any other questions in the chat. So again, questions go in the chat, addressed to all panelists, and we'll make sure we get them answered here. So we're going to move on to Matteo.
Hey, thanks, Dwight. Welcome to NetApp Support's second installment of Knowledge and Know-How. As Dwight mentioned, my name is Matteo Novakovici. I'm a storage grid escalation engineer. I've been with the product for about 10 years, and I'm based out of sunny Vancouver, Canada. Today I'm going to be talking about managing storage grid alarms. But I mean, that title really should be managing storage grid. All of the tips and tricks that I'm going to be getting into today are essentially to make your day-to-day operations managing your grid a little more fluid and keep your grid running fluid or keep your grid running optimally. So on the agenda for today, we're going to be talking about email notifications. We're going to be doing 3 quick little video demos on setting them up, customizing them, and suppressing them. But during that customizing topic, I'm going to break out of the PowerPoint and jump on a live grid to kind of give you a more of a feel of the customizing process and why it's important to customize these alarms. Our second topic is going to be acknowledging alarms, sort of avoiding common pitfalls, best practices, when to acknowledge an alarm and when not to acknowledge an alarm. Our third topic is going to be the top 3 storage grid alarms and their solutions, and I'll obviously get into a little bit more detail of that during that topic. All right, so email notifications. Storage grid much like many other solutions, offers the ability to send an email notification whenever an alarm is generated. On this config page, you can see you simply inject your SMTP mail server configuration, the from address, and then you will, and then if you feel confident or not confident, send yourself a test email, and then you're halfway through the battle. If there's anything you can take away from my presentation today, it's to please ensure you have these set up, and please do what I'm going to say here, which is to customize them. And in this little demo, I go over it a little too quickly in this little time-lapse video, but I'm going to break away from this to give you an idea of sort of not a best practice, but just a tip. Maybe utilize this within your own StorageGRID environment. So let's go ahead and break away from this PowerPoint for a second. This is just a little test grid. I've already set up these customizations, but I'll go over them with you. Just head over to configuration, email setup. So the tail bit of that email setup is we've got you to the point where you simply are at the point where you are communicating with your email server. But what you have to do next is actually set up recipients of that email, right? So in this situation, I've actually set up 3 little groups, and you can see here, SGRID admins. Let's just say I'm one of 5 administrators that will receive this email. I've set up a catch-all, and I'll talk about why this is important. One catch-all email address, and let's just say I only want to accept major alarms, so I've kind of labeled it as such. So let's move on to configuration. So under configuration, notifications is where I've also already set this up just to make it easier to process. But you can see here only major alarms. If you can see that these three lists are the ones that I just set up, but and I'm only under only major alarms to myself, so I'm getting that. I'm actually part of all 3 groups in this scenario. But regarding the core admins, we've only set them up to receive notice and minor. Perhaps the StorageGRID admins that are the frontline support of our grid is only receiving notice and minor, right? They're just going to react to those types of alarms. The big one here is the catch-all, and if you don't want to be more granular at this level with customizing alarms, I really strongly suggest you create a catch-all email group or distribution, and make sure all your admins or any stakeholders responsible for the grid are on that list. And my takeaway here is if you can set up at least a catch-all here, you have one email address that you're all subscribing to. And with that in mind, you can actually customize your own email application to filter out messages based on sort of your grid's alarming nature, right? So every customer's deployment might have sort of different alarms that trigger at different times for different reasons. So the grid is sort of this living, breathing organism, and you might have to treat it like that, right? You might have to dissect what alarms are not important to you versus some that are. But as long as you have a catch-all, your email server will store a copy of that. So you kind of have an audit trail of all these events that have ever happened throughout the life cycle of your StorageGRID's implementation in that object store. All right, so let's head back over to the PowerPoint and carry on. Oh, sorry, we already did that. All right, so once you've set up email notifications, you have the ability to suppress them. And the only time I recommend suppressing email notifications is if you have a planned maintenance. So a little bit of a scenario, I'm a StorageGRID administrator. I have a network switch firmware upgrade on a weekend. And what I would do in this situation is I would simply suppress the email notifications, carry on with that network maintenance, and then I would unsuppress them. You can see here it only tacks on a couple seconds before and after that maintenance. The benefit of doing this is that I'm not going to spam my inbox and potentially anyone else on that group email distribution with potentially hundreds of emails. StorageGRID can be very chirpy, very noisy. If the fabric that touches every single service and node in your grid, we will alarm about that. But if you implement this one little step before and after, you can bring down all of those spammy emails. And the reason why I feel this is very important is because just think about your day-to-day operations, right? You go to your inbox, you have that storage grid folder with all those alarms. If you come in on a Monday morning with that cup of coffee and you have 300 alarms because of that network switch upgrade, well, you're going to slowly just get desensitized to this over your day-to-day operations as the week, months, and years go on. You're going to see these hundreds of emails, and you're not going to be able to maybe cut through the weeds, right? If you have all of those emails. So one quick little step is to suppress them before and after a maintenance. Right, so second topic is acknowledging alarms, but I want to take a couple steps back and give you an idea of what's happening under the hood when an alarm is acknowledged. So an event will trigger an alarm, no surprises there. That event, depending on the severity, will change the color coding. So if you noticed before, there was a minor, major, critical, an unknown, right? So what happens there, so what happens next is if you go and acknowledge that alarm manually, the alarm transition and the alarm clears, the event goes green, right? But, and this is a big but, the underlying issue, the event that triggered that alarm is actually still there. It's just cosmetically removed from your UI, right? That event still exists. It's still going on in the background. And this isn't part of the framework of acknowledging alarm, but I've added this little tidbit here to please review that event. If you know what the triggering event is, then I would say by all means, acknowledge it. But if you're not certain, please don't acknowledge it, investigate it. NetApp support is here to help with all of our NetApp products and all of our NetApp customers, right? So please create a case if you're not certain about it. Excuse me. So with that framework in mind, I'm going to give you a bit of a scenario on when it might be acceptable to acknowledge an alarm. And I use this example only during maintenances. So in my scenario, I'm a storage grid administrator. I have a site in LA, a site in New York. I'm creating one copy to each site, but I'm also taking advantage of StorageGrid's ability to tier off to a public cloud. So in this instance, I've created an AWS bucket and I'm tiering off a third copy to the cloud. And it's a Friday night, and I know that there's a maintenance happening on Saturday between 12 and 4 a.m. where my bucket is inaccessible. So I'm okay as an administrator coming in here. Notice the storage unavailable. That's kind of signifying that the underlying medium is not available. So I'm okay with acknowledging this alarm in this circumstance, because what's going to happen here is that the alarm clears and it gives me clarity on my grid. I can see, you know, if an unforeseeable event comes up, I can focus my attention on that and hopefully resolve that problem. But if I hadn't, then you can understand, you know, it just gets a bit cluttery, right? With all these alarms popping up. So review them as soon as you can. So when not to, whenever there's an unknown issue, right? So a very similar, I'm going to do another scenario, very similar to the last situation, except this time it's a Friday night. I'm going on vacation next week, which is actually about right, because I am going on vacation soon after this presentation. But anyways, I'm going on vacation. It's a Friday night, and I'm in a rush, and there is no planned maintenance of this AWS bucket. So this third copy, there's an alarm here, and I don't know why. But Mateo's doing a really bad thing here. I'm going in here, and notice the storage unavailable. This means that my bucket is not tearing off that third copy. But what I've done here, because I'm in a rush, I got to get back home, pack up the kids and go, I've acknowledged this alarm. That's a really bad thing. But you can see here, one simple alarm acknowledging can lead to very big consequences. First one, I'm not meeting my company's business SLAs, right? We don't have that third copy going. Second of all, the queues that, sorry, we have an ILM structure that is asked to do something very specific, and that policy is saying to create a third copy. Well, we're constantly trying to do that. So there could be a bit of a performance impact, or at bare minimum, wasted IO on trying to send that third copy, right? So that's happening in the background. I'm planning my vacation. Third of all, the people that are responsible for this grid while in my absence, they have no idea what's happening. They see a clean green grid, right? But if some issue happens during that week that I'm away, they are just going to see the grid as being green. They won't know what's going on. This could just brew and manifest, right? And for when I get back from a vacation from Bermuda or whatever, there's a very strong possibility I'm not going to remember that I acknowledged that alarm, right? I'm going to have hundreds of emails from planned maintenances that I didn't correct or I didn't acknowledge before. So I have that big inbox full of notifications, and I just was not a very good administrator in this moment in time. So cardinal rule, what you can take away from this is don't acknowledge alarms if you don't know their trigger. And another one is don't acknowledge alarms before you go on vacation. All right, so last topic, top 3 StorageGRID alarms and their solutions. Just a quick little briefing of each alarm. AMQS stands for audit messages queued. The second alarm or the second event is VMFR, which is volume free or space available. And the third alarm is SAVP, total usable space in percentage. All 3 of these, what they have in common is space issues or lack thereof space, I should say. All right, so first alarm, AMQS. You're going to see a very popular theme amongst these 3 alarms, and it's to please review this alarm. If you don't, that disk that houses that queue will slowly fill up over time. If you choose to ignore it or acknowledge this alarm, what could end up happening is the disk space could be used up until you get to a couple meg, and then ultimately 0 bytes free. That will create instability and a possible crash of the node. Analogy that I would like to use here is picture your Windows C drive as it runs out of space. You can imagine your applications are not loading or they start to error out. If you get to the point where you have a blue screen of death and you have to reboot and you notice that you have to go into safe mode and you have 0 free space, you have to start freeing it up, right? So same kind of scenario with StorageGRID. We're only as good as our weakest link. And if there is disk space being used because the queue is filled up, then you will run out of space, and you can kind of see kind of like a domino effect happening within your grid if these queues are building up all over the place on each node. So on the right here is a graph of an example of these audit messages as they're queued. So in a healthy functioning audit relay and framework, what happens when an audit message gets generated, which happens on every single node in the grid, an audit message will get created, and that instantaneously and in the flesh in the moment gets sent to an audit relay, which is a StorageGRID node with an ADC service. However, if say that StorageGRID node with an ADC service is down, this message will queue up on the node that's generating it. And in this example, you can kind of see, I'm not sure how clear it is, but there's 2 blue lines on the left there, which indicate an unknown status. And the moment that happened, these queues built up on this node. And they start to gradually happen over the next, day and a half, until they plateau at 13 million. Well, what happened here is that this node was not able to send its live raw audit message to the audit relay. So it built it up locally until it got to 13 million. But when it plateaued and there's no more processing there, that's actually an indication that the disk is full. So it can no longer process them anymore. This is a scenario that you don't want to have your grid into. So don't acknowledge that alarm, don't ignore it. Please review it ASAP. You already kind of understand the consequences of doing so. So common triggers of it. The sustained activity rate could overwhelm the actual availability of space to process it. So this meaning that you, let's just say you did a big batch ingest, you just onboarded StorageGRID and you are ingesting, 50 terabytes a day. Well, those 50 terabytes also have an audit message stating that, oh, this was ingested at this time by this client and it went to this storage node. Well, if the activity rate of the audit system or the audit attributes going to the audit repository, the capacity, and if that capacity is not big enough, you will start to see AMQS build up because it simply doesn't have the space to process it, right? The end system. Another trigger could be that your admin node, which is houses that audit capacity, is down and can't accept that message to put it into the audit log. And also another one that comes up is the storage node with an ADC. If that is down, that is the medium that will either relay it or process that audit message. So if it's down, queues will build up on the nodes that were destined to send to it. Connectivity issues is always a big issue, but if you are having connectivity issues, you probably have a lot other bigger fish to fry than worrying about your underlying audit management system, right? If you cannot connect to the grid, your customers, your clients, your applications are going to be unhappy. But this will be another reason for that AMQS alarm ticking upwards. And the last one is disk space, and you can kind of see how they all kind of connect in a way, right? So if there's no disk space on that node, that what I was mentioning as an audit relay is a storage node with an ADC. If that becomes full, then it cannot accept messages, and it's not gonna, well, I mean, if it cannot accept messages as fast as it can relay them out to process, then it's gonna hold on to that queue. So this is another reason why this queue will increment slowly. All right, so with all of that in mind, some common solution is to really not do anything at the troubleshooting layer, except monitor your grid, monitor the node that actually had the AMQS alarm triggered. And you can see here from these examples, you kind of see a noticeable uptick in network traffic, right? Overall, take a look at client load. If there was literally more puts or gets or heads during this operation, and it was just a little more than your storage grid can handle, you might see the AMQS alarms trigger. And this is not a big deal because we do prioritize client transactions over these sort of subsystem calls where we're just relaying audit messages. So if you see a blip and that aligns with your audit message queue going up, and you see your resource going back down, and your AMQS usually follows suit. There isn't really anything you need to do in this circumstance other than monitor the grid, but at the same time, don't ignore it and don't acknowledge the alarm, because if this isn't the problem, then you don't want that to manifest and potentially create an unstable system and create that trickling effect on other nodes in this distributed environment. So another solution, if monitoring those resources doesn't lead you to a solution, or they sustain themselves and keep queuing, what we'd recommend here is to actually change the verbosity of the audit levels, which can be done through the configuration page on the StorageGrid UI. So essentially, if you are generating 20 gigs of audit messages a day, you can kind of dumb that down a little bit and turn off certain features so that you bring it down to only 5 gig a day, because maybe you're doing a batch ingest, you just onboarded and you have like 500 terabytes to ingest. Well, you can, for the intermediate period, take your foot off the pedal a little bit for this particular portion of the processing, and that will allow those queues not to build up so high and allow for processing. And if this solution doesn't help, contact NetApp support, and we will gladly try to look into whatever might be the cause of these AMQS either continuing to go up and up and up. So our second alarm that happens quite a bit is VMFR, which is actually just the local disk space on whatever partition this alarm has been triggered on. Again, please review this ASAP. Make sure that you review it before the disk fills up. The exact same scenario and the exact same analogy can be applied to that AMQS alarm. I'm not going to bother getting too into that. But you can see here, this alarmed on the root file system, and the trigger was 1.95 gig available. Solution in this circumstance is to literally SSH to that node, log in as root, and review for rogue files. I have an example here of a very large file that shouldn't be here. Review files that don't look like they should be there, and either move them to another partition on that disk, or move it off to another storage node or another share, SCP it to some other system, and try to free up space that way. If it's not some rogue file, excuse me, have a look at any crash kernel logs that may have been triggered. Usually that is, the system was running fine and everything in memory gets dumped immediately to a log file called the crash kernel if there was some sort of event that triggered this. Remember those two blue lines? That could have been the reason why, right? There could have been a very large crash kernel, and the node was blue during that time, and now there was no space on that file system to store those AMQS alarms, or sorry, those queued messages. So simply just review it and remove those files that are on there. So the next one is SAVP. This is essentially your object store, your bucket, your single namespace storage grid environment does not have any more space or is running low on storing data. And if you avoid this or you acknowledge these alarms, your nodes nodes will go read only. The consequences of that are pretty straightforward. You will not be able to ingest data. Again, popular theme, don't ignore it, don't acknowledge it. Please review it ASAP. Solution, and this is a lot easier said than done, but if you catch it early enough, you can either expand the storage grid system. I know this could take a little bit of planning, right? Getting the hardware, rack and stacking, expanding, going through the process of expansion. This all can take time, but if you catch this alarm early enough, you can plan for this and avoid it. You also have the opportunity to tier off to a cloud storage pool, like I was demonstrating with that AWS bucket, or removing client data altogether. But again, we don't recommend removing client data. Removing data is typically a very expensive operation because for every piece of content you delete, we have metadata that has to agree on the deleting of it. So for instance, if you have a storage node down and you're trying to delete data, and that node that's down houses one of those metadata records of that object, we're not going to delete it yet until everyone agrees that this object can be deleted. So it's an expensive operation, and we don't recommend removing client data. We recommend being on top of these alarms and expanding your grid if you need to, or move it to a cloud tier. So that ends my technical portion. Does anyone have any questions?
Hey, Matteo, there is one question in the queue, and Christoph wants to know, are the alarms recorded and available from ASAP? I would assume also AIQ, or basically are the alarms sent to NetApp?
Not the, you know what? Let me get that, let me jot that down because I don't think that they're available that way. I think that they only get sent through that, that medium that I was already saying, right? Through, when you get sent that email through your mail server. But I'll have to take a look at that because we're always making ASAPs more robust within storage grid, but I'm not sure about that actual topic. Let me get back to you, Christoph.
Yeah, so Christoph, if you can provide your email address into the chat to all panelists, we'll make sure we get back to you after the webinar. Yeah, also, Asha wants to know, can a SMTP config with a public provider such as Gmail or Yahoo be used for sending email notifications?
Oh yeah, so if you don't have a company email that you want to relay to, essentially. Okay, yeah, in fact, I did this demo with some public email. So as long as your admin node has, can talk DNS and can get on the internet, we could forward that to an external SMTP server. Yeah, that's possible.
Okay. It looks like there's no more questions in the queue, so let me move on. After this session, you're going to receive, we've already mentioned, you're going to receive the slides. You're also going to receive the webinar recording. You're also going to receive a survey. Please take a few minutes to fill out this survey. Let us know how we did. Let us know what you want to hear about in future webinars. We're going to be doing these quarterly. So please let us know the topics that you want to hear about. That's what we want to be presenting here. If you have any follow-up questions from this webinar, or if you want to shoot us an email and ask us something else, you can send us an email to ng-supportwebinars@netapp.com. We also have some upcoming events. So the next episode of Knowledge and Know-How will be February 19th, 2020. And also we're working on something called regional support conferences, and there'll be more to come on those in early next year. So I'll check one more time. I don't see any more questions in the queue. We're almost at the top of the hour. We do have some reference material. These will be sent out as part of the slides. You'll be able to just click on these. The first one's the support site where you can reach NetApp support, and the others are some of the content we covered today. So if there's no further questions, I want to thank you again for joining us for today's episode. Please look for the invite to episode 3, which again is in February, and hope you have a great rest of your day. Thanks a lot.